Hello everyone, in this video we will learn about magnetic effect of electric current. So to understand this we have to perform an activity. So first of all we have to take a matchbox and we have to remove all the matchstick from it. Now we have to wrap few times a wire on it on this cardboard tray, and after that we have to place a small magnetic compass or magnetic needle inside it. Now we have to connect the free ends of the wire to a electric cell, and we have to also connect a switch like this. Now, near this arrangement, we have to place first a magnet. So suppose one magnet we are bringing near to this magnetic compass, so we can easily see the deflection because magnetic compass is also having a small magnet in it, so it can easily attracted by the another magnet. Now we have to remove this magnet from here, and after that we have to turn on the switch. So when we turn on the switch, what will happen? We will see that the needle will get deflected when the current is passed through this coil. So why it is happening? Because reason behind that, whenever we are passing the current inside the conductor, any type of wire or any conductor, it will behave like a magnet. And this is known as the magnetic effect of electric current. And this type of effect is first observed by a scientist named Hans Christian Ørsted. So he was the first scientist who observed this, and we can easily use this principle for making the magnets. So whenever we are making the magnet by using the electricity, we called it electromagnet. So for making the electromagnet, we need a insulated copper wire or insulated wire around 75 meters long, and we need a nail like this, and after that we need a switch and a cell or a battery. So in this, first of all, what we need to wrap or we need to wound this wire, insulated wire, on this nail like this, and the two ends of this wire or free end of this wire we have to connect with a key and a battery. So once we connected this apparatus, when we are switching on the circuit, and if we place some all pins near to the apparatus, what will happen? It will easily attracted by this system or this complete apparatus. The reason behind that, now the nail will become behave like a magnet. The reason behind that, whatever the magnetic effect which is produced in this coil, it will directly transfer in this nail, and now this nail will become a magnet. So this magnet can easily attract the small all pins. So that is why this type of arrangement can, we can say it is a electromagnet. Now if you want to increase the power of this electromagnet, so first of all we can do two things. First thing, we can increase the number of turns on this nail. That means if at the starting we was using that 20 turns we are using, so now if we increase to 40, then also the power of this electromagnet will increase. And if we are not having the so much long wire, then we can increase the power of the battery. So suppose at the starting we are using 2 volt of battery, then we can use 4 volt, 6 volt, 8 volt, whatever the number of batteries we can attach it. So we, if you want to increase the power of electromagnet, then we have two methods. First, we have to increase the number of turns, and second, we have to increase the number of batteries inside this apparatus. So this is how the electromagnet works. And this type of electromagnets can be made very strongly or very powerful electromagnets we can make so that it can easily move the heavy object also. So this type of electromagnet can use in different type of places. For example, if you want to collect all the magnetic material from the scrap, then we can use it, or we can use it in the electric bell also. Now this is a diagram of electric bell. In this, what is having, first of all, we are having a bell that we call the gong, and we are having a hammer, and this hammer is connected to a small strip. This is a small strip which is basically made up of a flexible iron strip, and it is connected to a small pointed here. And this point we can easily say it is a switch. So if we are saying that this is the switch A, then we assume that it is the dummy switch. So it will be switch B. Now what is happening? This thing, this is a electromagnet that we learned earlier. So this is the electromagnet that is here. So this is a simple iron bar which is wrapped with a insulated wire. So it will behave like electromagnet whenever we will pass the electric current in it. So once we are using this switch, so what will happen? It will connect the circuit, and whenever it will connecting or it will on the switch, what will happen? Whatever the hammer and strip is there, so this hammer and this complete strip, it will start moving or it will attracted by this electromagnet. So this will move here. So whenever it will move at that side, it will hit the gong. So once it will produce a sound. Now, when it is moving at that side, it will lose the connection from this small pin because it will move here. So once it is moving there, what will happen? It will be like this. So now it is no longer in the connection with this pin. So that is why the circuit will again break. So it will behave like a dummy switch. Again, whenever the circuit is break, this electromagnet will stop working and the hammer will again come to its original position. That means here. So once it will again come to the original position, what will happen? It will again come in the contact with this pin. And again, if the circuit is completed, it will behave like a magnet. It will attract again. Again, it will hit and it will continuously hit and stop till we are using this main switch. So once we are leaving or once we are relieving this type of switch or this switch, then only the bell will stop working. So this is how the electric bell works.